All right. Hello, everybody, and welcome to the stream. I hope everybody's doing well tonight. We are picking up where we left off last time, except we've got some really good news this time around, which is awesome. So, last time we kind of left off just with we were having some issues with our shadow mapping system, trying to get that to dynamically follow our camera around. And I went ahead and figured that out off screen, just because I didn't really want to devote any more stream time to that, because you guys kind of saw how I was debugging it. And so my first thought tonight is going to be to review what those fixes were and take a look at what we have. And then, as the title mentions, we are also going to get into cascading shadow maps tonight. So that is what is on the roster, and if we have anything in addition to that, we'll go ahead and tackle that as well. I've got a couple of ideas of some things that need to be done also, so we may get to some of that stuff tonight. We'll see where we wind up. All right, so before we jump into that stuff, though, I do want to take a quick second and just thank the supporters of the channel, beginning with the partners. They are the highest tier of subscription over on Patreon and YouTube memberships. They are Arslia, Gebi Bashir, and Gerbolis Inc. I would also like to thank all the other supporters listed here on the screen. They are the other tiers of subscription over on Patreon and YouTube subscriptions, as well as Twitch subs. So thank you guys very much for your support. I greatly appreciate it. Of course, I hope it goes without saying, rather, that I also appreciate each and every one of you viewers, you guys that are coming in, joining me here on stream, whether it's on YouTube or whether it is on Twitch. We are simulcasting. So without you guys, obviously this project wouldn't exist. So thank you guys for being here. I appreciate that very much. So with that said, this is designed to be an interactive stream. So if you're new here, then basically just if you have any questions about what we're doing here, or you just want to stop in, chat, say hi, whatever, that's cool. I'd like to chat and talk with you guys as we're going through this stuff. So, all right. So, with all that stuff out of the way, I want to take a quick second and just kind of go through kind of where we're at. And actually, I think probably the better place to start is to kind of show you guys, where we're at. So let's do that. I'm going to pull up our debugger here, and I'm just going to go to our testbed main, just because we've got one small thing here I want to make sure of. Okay. And so ultimately, what we were doing last time was we were kind of trying to visualize what our both our view frustum was, as well as our shadow frustum. And that was kind of where we left off last time. So let's take a look at what we have here. You'll notice that I've got something here called hack enabled. That's basically just a little hack I put in place just to sort of look at that secondary camera that we had in the scene, and use that as our basis for generating the shadow maps. That way we can kind of look at it from all sides, right? So we'll go ahead and run this. All right, then I'll pull this down so you guys can see it, and I'll load up the scene. And I'm just going to back the camera away a little bit here. And we're going to see a few things happening here. So one of the things that's happening is we have our sort of test hack camera that's here, right next to this car, right? And what we've done is we have visualized the view frustum from the perspective of that camera. So actually, if we zoom in really far here and look at the back of that view frustum, we can see that the near clipping plane is in green there. It's really tiny, right? And that's because the near plane is very, very close. And then the far clipping plane is actually represented by this red, right? Which is clipping into the terrain right now, and that's fine, right? And then what we did was we just have it spinning around and around so that we can see the results of moving that camera in the scene, and we don't have to sort of do it manually. And the other thing that we can see here is that the shadow map is kind of moving around, which is exactly what we expect, actually, because the other thing that we have visualized here is our shadow view frustum also. So it is a orthographic projection, right? So it's square. And this is the near plane of that. And then the far plane of that is underground down there. Okay? And basically the way that this is working is it is shooting an image of everything within that box. So if we back out a little bit further, we can actually see that that box is kind of moving around, kind of comes into Sponza a little bit, right? As it sort of moves around. And the reason it's moving around is because it's based off of where this projection matrix is, or where the projection frustum is, rather. And it's basically doing a radius check on that. We'll see that in a minute. And it's dynamically recalculating this every time that moves. So this is just the sort of visualization of that. And then if we look and kind of pay attention to where these lines are, we'll notice that the clipping of the shadow lines up exactly with that, right? So we can see exactly where this is in the scene. And as we move this around, we can see how the frustum kind of moves with that and kind of clips things out and whatnot. So what this means is, from the perspective of the camera, there is never anything unshadowed. Everything is included that is visible within that shadow, okay? And this particular camera has a very short view distance. I think I've got it set to like 10 or something like that. And that's purely for the purposes of this demo, right? Just to kind of show you guys how this is supposed to be working. So that is what we were trying to sort of achieve in the last couple streams. So, all right. So what I'm going to do now is I'm actually going to turn this hack off. And what this is going to do is it's going to shift control of that projection to the actual camera that we're viewing in scene. And so that's going to switch us back to our world camera and our world projection matrix. And we're going to see something vastly different, and perhaps maybe not what you expect. So we'll go ahead and load up the scene. And we see here that we have a static image, right? The shadow map's no longer moving around, and that's kind of what we expect. However, we can see that our shadow map is got a bunch of artifacts here, or at least what looks like artifacts, right? And as we move this around, we can see that it sort of jitters, right? And what's the reason for that jitter? Well, if you look, this is actually a single pixel off of that shadow map. It's huge, right? And the reason for that is because our camera's view frustum extends very far into the distance. So what we're seeing here is that shadow map being stretched out over basically 400 units is what we have our perspective projection set to. And so if you have a single shadow map over a very small area like what we are looking at here, sure, it looks great, it looks crisp, it's fine. But when you stretch that out over an entire scene, this is kind of the result that you get. And obviously this is not ideal, right? This is not what we want, obviously. And so we have to have a way of actually dealing with this problem. Because you can't just use, I mean, yes, you theoretically could use a bigger image, right? We're using a 2K image here for our shadow map. We could theoretically just increase the size of the shadow map and have it look better, right? But if you're looking out into the distance, and obviously none of this stuff is shaded because it's all just flat terrain and the sun is kind of coming down from above. But if you had a whole bunch of stuff that was, over the edge of a cliff that you were looking at that had to be shaded as well off in the distance, you don't want that stuff to necessarily have the same amount of detail as something up close. And that's where shadow map cascades come into effect. So shadow map cascades are actually what we're going to review tonight. But before we jump into that, I kind of want to just go over the changes that we've made in order to get to this point. And those changes are actually already pushed up to the repo. So we made those changes earlier, and we've already pushed those changes up. So I just want to kind of quickly review that set of changes. So let me just pull up my repo here. Where did that go? Here we go. All right. And so we had 2 commits So we have dynamic frustums working with shadow maps, also turned off builds and tests for tests and tools for now. And that's because we're not really using the tools or the tests at the moment, so I just turn those off so they don't rebuild every time we build, just to kind of speed up our iteration a little bit, right? And then we also fixed various math bugs revolving around frustums and culling, which we actually still have some work to do on that I found out earlier today. And then we also added some queries to simple scenes for geometry render data and moved frustum culling there. So if you recall, before we had this sort of big duplicated section of code for frustum culling for the scene and then for shadows. That's all done in one place now. And so we'll briefly touch on that. So if we take a look at this first one, there's not a whole heck of a lot here. It's just a few files that have changed. So these are the build scripts. We don't really need to review that. I just turned off processes. In Kmath, we've added a ceiling function that just calls to CLF right now. Again, eventually we'll probably implement our own one of these. And then we have frustum corner points world space. And this time we get it from a projection view matrix. So that's those two matrices multiplied together. And so we take that and then we create these corners based off of that. So the general idea there is we basically build an orthographic matrix. And this should probably be named to reflect that perhaps, because I don't think this works with perspective. But we basically take a orthographic perspective, or orthographic matrix rather, and then we take the inverse of the projection view and we transform all the points that we extract by that. And that's it, right? So that is essentially what that does. Nivlak, hello. How's it going? Good to have you here. Good to see you. The other thing that we did, we defined a couple of constants for kfloat and kmin. You guys have seen some of this stuff already before, so I'm not going to kind of jump into it. We added some functions here to multiply vec3s and vec4s by scalars. Remove some dead code. We added a convenience function to extract the position from a matrix 4. That's formatting. This is formatting. And then this is the just the declaration of that function, right? Naxnir, how's it going? It's going pretty good. How about for you? Going good over here. We're just going over our fixes for shadow maps at the moment. So welcome. Good to see you. So that is it for this file. And then in our shadow map pass, we basically just kind of cleaned up and got rid of a lot of stuff. There was a lot of stuff that we were doing in here that I thought kind of made sense to do in here that I sort of decided against later on. And so we do still set up a default viewport. However, we no longer take in an FOV near clip or far clip in the config. We just use zeros for those. And the reason behind that is because we just need the viewport rectangle for this. We don't actually need anything else out of it. So that's all that's doing, with a note there to that effect. All of this stuff here where we were generating projection matrices internal to this, we no longer do that. We actually generate that outside of this because we need it in several places and pass it over to this. Nivlak, it has been a while. Yes, indeed. Yes, it works now, Naxnir. Yeah, actually, so I'll just demo it again real quick. So I have this little hack in place, just to, remember how we had sort of a second camera in the scene where we were, sort of visualizing the view frustum of that camera. So basically what this hack enabled does is basically allows that to be true. And then what we do is we rotate that camera just constantly. And then we're also visualizing the ortho projection matrix as well for the shadow map. And so when I run this, we can see that let me back off from this a little bit. So we can see our camera's matrix here spinning. right? So the near clipping plane is that small little green thing that's here, right? That's the near plane. Right? That's the near plane right there. It's really small. And then the far plane is that red box. And then obviously the yellow is the connecting lines. And then we have our ortho matrix, or ortho projection rather, which is represented in a similar fashion. So it's ortho, so it's square, right? And so that's the near plane, and then under the terrain here is the far plane. Okay, and you see that's moving around because our camera is rotating. And then basically what we do is we do a radius check on all of these points to get the max distance. And then we just generate our ortho square, for lack of a better term, off of that, right? And you can actually see that working here. You can see this kind of clipping the shadow right there to this. So this camera has a very short cutoff for its far plane, just to illustrate that cutoff, right? And so that is where we're at. And then if I go ahead and turn the hack off, and run it again. We can see now that we are getting another version of the shadow map, right? But this is stretched out to fit the cutoff of this actual camera, which is about 400 units. And we can see that the shadow map is actually really stretched out now. And it's jittering because as we move that around, the camera around, it's sort of recalculating, right? And so obviously, this isn't ideal, but this is the necessary step that we have to take. So in order to shadow map the whole scene, we're actually going to need cascading shadow maps. And we're going to get into that a little bit. But our basic shadow map works right now. And then in order to get more crisp lines up close, we're going to use cascading shadow maps. So we are going to jump into that tonight. But our shadow maps actually do kind of follow this around correctly, right? So even if we go in here, this is very jittery because it's stretched out so far. So the shadow maps will solve that issue. Okay, so that's kind of where we're at. Let's see. We make the shadow map camera move by pixels instead of consistently. What do you mean by that? What do you mean move by pixels instead of consistently? Incidentally, you guys on the YouTube side, if you have any questions, feel free to jump into chat as well. I do watch both chats, right? So most of the chats I've been interacting with are on the Twitch side thus far. But if you guys have any questions, feel free to jump into chat, right? All right. So what we were doing was we were kind of walking through the changes to get to this point, right? So there were two commits. There was this dynamic frustums working with shadow maps. And then there was this one here where we fixed a few more math bugs. So we're kind of going off of that. Move on the grid of the shadow map so it doesn't flicker. Grid of the shadow map's pixels. So we're not going to have to do that once we get our cascading shadow map in place, because you're not really going to see it. And so we'll take a look at that once we get there, right? But cascading shadow maps are really the answer here, right? And also different types of filtering could also help with that. Doesn't that just solve it by making it smaller? Essentially, but it's using multiple shadow maps. That's essentially the idea there. So you want to use a really large stretched out shadow map for the distance, and then you want to use a tighter, smaller shadow map for up close. And then obviously in between that, you'll have different sizes. Taman, good to see you. Welcome. How are you doing? Welcome to the stream. All right. So, let's see. So we have most of this stuff is like reformatting stuff, comment updates, or changing from using passed in or the internal data to passed in data, right? So that's actually the rest of what those changes are in the shadow map pass. We removed all of this stuff from config on the shadow map pass because that stuff is no longer stuff that we care about being passed in. Debug box 3D, we created a function which I didn't wind up using, but I left it in anyways, just to be able to set the points of a box 3D. Before we could kind of set the extents of it, and it would basically regenerate these points, but this actually allows you to set those points in space, right? So that's that. That's the header file. Versioning, not really important. The game state just has a few things here for our debug shapes. So we have a projection box index, which is the index of the test boxes, and then the projection line indices, which is the indexes within the test lines array that we already have. So we'll see that here in a second. Okay. All right. So I am doing okay, Taman. Thank you for asking. I appreciate it. Can't complain. We're basically just... I'm actually doing a lot better since this stuff is actually working, right? It was really, really annoying me that it wasn't working. But that's kind of the way it goes sometimes, right? Okay, so the scene pass, we put a to-do in here about the terrain materials themselves. So the entire terrain shares one material. So a lot of this stuff should probably be moved to global for the material shader, texture maps, surface properties, but leave the lighting at the instance level. I haven't made a decision about that yet, but that was something I was thinking, so I just kind of noted it. All right. So testbed main, this is where most of the changes were made. In fact, I think this is all the rest of the changes, so this won't take very long. We cut the viewport down from 4,000 to 400. I thought that was a little bit more of a sane distance. And that also helps with our shadow map. And then we basically wound up using the world viewport rect 2 that was used for our orthographic wireframe view before. We just wound up reusing that for our test. And so we basically just created a fake camera using that. If we go a little bit further down, we just changed the default camera position and rotation just to kind of put us a little closer to what we were looking at, so we weren't so freaking far away and had to zoom in every time. And we did that also for the world camera 2, which is what we're using as our test. And then here is the frustum visualization, right? So we have a center box, which I actually forgot to show you guys, but there's a center box that shows where the center of the V frustum is. So that's something that gets drawn, and then we basically loop through each one of the lines. So we need a total of 24 lines to show or visualize both frustums. So there's 12 lines per frustum. 4 of the lines are for the near plane, 4 of the lines are for the far plane, and then 4 more are for the connecting lines between the two. So we have all of those here being created, complete with color information. And then we just kind of came through here, and in prepare frame, we kind of cleaned up a lot of this stuff. And so we basically marked the shadow map pass for execution. We set the light on the extended data, cleaned up a lot of comments here. Here's the hack enabled stuff that I was showing you guys. So there's that. Again, more cleanup of dead code. Getting the world space corners of the view frustum, that's nothing new. More dead code. And then we calculate the center just as before. The difference is instead of calculating the corners, or handling the min-max and trying to generate a ortho matrix based off of that, all we do is we keep track of the largest radius. So we take a distance between each of the corners and the center, and we say, hey, take the largest one of those, and that's what we're going to generate our extents based off of. So our extents now becomes a lot simpler, right? It's just radius and negative radius, essentially. And then in our Z multiplier, and again, I have a to-do here to allow that to be tuned per scene. So this logic is the same as it was before. Our look at and projection are the same as they were before, based off of the extents. The main difference between what we had before and now with the shadow camera projection is the min on the z-axis is min z, and the max is max minus min. That's the main difference there. And then we also save these off to the past data to be used. And then this is all of the frustum visualization stuff. So I kind of put this in a block so I can delete it later. And so we basically repeat the process above. Wait, no, I think this is for the... Yeah, this is the... Yeah, this is the shadow camera. Okay. So we basically repeat the process that we did before for the shadow camera for the regular camera. The difference being is we actually combined both of these steps into one. So we have this 2 here. So the first one, iteration of that is for the regular corners for the regular camera, and the second one is for the shadow corners. It was the same logic in both places, so this just makes it a little less repetitive. And then we also set the transform of the test box to the center of the projection matrix. So that's that little marker that we have to denote where the center of the projection matrix is, or the average, we should say. All right. Let's see. We had some dead code replaced by more dead code, but that stuff's going to be coming back. We did turn off shadow frustum culling for the time being, at least here. And I think the rest of this is pretty much dead code elimination and a small tweak to our world viewport rectangle 2 on resize, but that's about it. Right, so that's that was one of 2 commits to get us to where we are. The second one is this guy, which isn't quite as large as it looks, I promise. So we just added some stuff to the change log, updated the to-do, which incidentally I'm going to have to update that a little bit more too. And then we changed the cull mode to none on this shader because it should have been none. It was still just front. We keep track now of the drawn shadow mesh count. So that's something that we show on the screen. So we'll see that. We added a couple of functions. So we have one for atangent or arctangent, in addition to what we added before. And then we have here frustum from view projection. So this is just to generate a frustum structure based off of a view projection matrix. And then further down, we have in the frustum create, we have a couple of small tweaks here that we did to that just to kind of clean that up. And then this is just a formatting change is all that is. This is, I think most of this is actually formatting. So we're going to have ads here in a second, FYI. So let me collapse these guys. Hi, from your experience in the Sphere, is it common to write game engines in C? I wouldn't say it's uncommon. I would say what you get a lot of times is a combination of C and C++, or C like C++, if that makes sense. Because a lot of modern C++ doesn't run on consoles, for example. So generally you get a mix sort of between the two. And when I say C like C++, I mean C++ written in a more C-like style. And we have ads. So for those of you who are new to the stream, we pause for ads so that nobody misses any content. And the reason for that is this is a programming stream, so it tends to be kind of detail-oriented. And, out of respect for our viewers, I'd like to pause the stream during ads. We generally get about 90 seconds of ads every 30 minutes, I think it is. And so I'd like to just sort of to go ahead and pause that, right? So we've got about 45 seconds left, and it also gives me a chance to get something to drink too. Raposita, thank you for the follow. And then, in fact, I'll say thank you again here in 20 seconds if you weren't able to hear me because of ads, but I appreciate that. So yeah, we've got about a little over 10 seconds left, and then we can get back into it. All right, ads are dead. So I like to just pause the stream whenever ads come up. Mostly on the Twitch side. I know YouTube, you guys don't get ads the same way that Twitch does over here, but I like to pause the stream for that minute and a half every 30 minutes just to make sure that nobody misses any content, right? So Raposita, if you didn't hear me because of ads, thank you for the follow. I appreciate that. All right. Kmath, we basically just have the declaration of both of those functions we just talked about. Math type, we went ahead and put in an enumeration for the indices of the frustum sides. That's to kind of get rid of some of the magic number business going on here, right? So if we take a look at this guy, instead of just 0 through 6, or 0 through 5 rather, we do that instead, right? So it's just a little cleaner and easier to understand that way. All right. Oh, there was one more thing there. Oh yeah, it was just changing the 6 to that constant, right? All right. The other thing that we did was we added a generic sorting utility method. I actually forgot that I did this. And so the easier way to explain this would probably be from the interface, right? So this works kind of like you would expect. It's a quick sorting algorithm. And so we basically have a couple of utility methods here. So we have a pointer swap, which basically says, okay, I've got this scratch memory that's of the size it needs to be. That size is passed here. And then we have a pointer to A and a pointer to B. And it basically takes what's in pointer A, copies it to the scratch memory using this size, then takes what's in pointer B, puts it in pointer A, and then puts what's in scratch memory in pointer B, right? And that's used repeatedly within this quicksort, right? So we take the size of the type here, the data itself, which is an array, the low index, the high index, and then the compare function. And the compare function can be provided right here. It just takes void pointers so that you can provide a function for whatever kind of data you actually have. And so that if that's numbers, you can provide a function for that. If you have specific structures like we do, you can provide that as well. So yeah, that's basically what that does. And then this is the quicksort implementation we already had from previous stuff. It's just generic now. So we have that version. We don't need to worry about that. And the scene pass, I think we were just switching. Let's see. Oh, I think I just did some formatting changes here. Yeah, I just got rid of some extra parentheses. Simple scene is where probably most of the updates for this happened. And so this is where we basically moved our geometry distance, and then our render data and distance compare functions for the sorting of those things were all moved here into simple scene. So that way we don't have all this stuff elsewhere. We can just kind of do it here. And so we added two functions. Actually, I'm going to go to the header file so that we can actually look at those. So we added two functions here. One to query mesh render data. So when I say query, we provided a scene, a frustum, and then basically the camera center, and then any frame data that's relevant. And then we return a count of the number of objects that match within this frustum, basically. And then a list of those geometry render datas, right? And we have the same thing here for terrain types. So it also returns this render data type, but it's a separate entry point because it's separate geometry types under the hood. And so basically the way that both of these work is if you provide a frustum, it returns a list of objects that are within that frustum. And then if you don't provide a frustum, it returns everything. So that's essentially the way that those work. So I'm not really going to go into that. This is basically all of the culling code that has just been moved in here. And I just basically picked it up and slammed it down in here, right? So we still have our bounding sphere calculation if we wanted to use that instead. So we may extend this later to make it a little bit more robust, but for now, that's where that lives. Okay, so that is that. And then the last guy is this testbed main, which has some changes, but most of it's deletes, actually. So we added shadow pass draw count here, which is this guy. And then we deleted a whole crap ton of code, right? That's all that sorting stuff that we had to implement separately. That's all gone now. Here is where our hack enabled stuff was kind of tweaked a little bit. We tweaked our position and look at a little bit. And then the shadow view and the shadow frustum. And then we were able to also remove all of this logic as well, which is awesome. So all of that is replaced with this, which is much, much better. And then here we track the number of meshes drawn for that, right? All of this logic to get terrains is now this. Okay. And then, so that's our shadow map pass. We did the same things all the way down for the view pass, or the scene pass rather. So we were able to, again, get rid of this, which was a bunch of repeated code, and replace it with this. And we were able to get rid of this sorting logic because that's also handled in here. And then we were able to get rid of all this and replace it with this. Right, and again, we have drawn mesh count here. So it looks like a lot of changes. I mean, it is a lot of changes, but relatively quick to review. And that catches us up to where we are currently. Ads suck. Yeah, ads do suck, but, you know, if I didn't run them, then there would be pre-roll ads, and that's worse, right? So it's definitely much better. Mods should be immune to ads. Yeah, I wish it worked that way, but it doesn't. I mean, but subs are, though. Or Twitch, what is it? I want to say Twitch Prime, but that's not right. What is the, what do they call it? It's not Nitro either, that's Discord. Whatever that thing is that Twitch has. I forget what the name of it is. LSR, hello, welcome. Good to see you. Welcome to the stream. All right, over on the YouTube side, I think your name is in Russian, and I have no idea how to pronounce that, so I'm not even going to try because I'll butcher it. But hello, are you using Vim only for writing and VS Code for debugging? Yes, right now. Yeah. So when I code, in fact, I have Vim open, right? So when I code, I do it in here. But when I debug, I'm doing it here for now. Retro U, a bit late. Was last week's issue truly foobar in math class? Yes, it was combined. So there's still some stuff I don't quite comprehend, but yeah, There were a couple things in the math class that were wrong, and there were also a couple things that I was doing on the user side of it that were wrong. It's pronounced like Victor Titov. Okay. See, I never would have gotten that. That's interesting. Okay. Because the text on that looks very... And just so I can... I'll just capture this so that folks can see. I never would have guessed that that's how you pronounce that. Let's see. Why does it... Okay. There we go. I never would have guessed that's how it's pronounced. Why are you not using NVim DAP UI? So I actually do have that installed, but I had multiple issues with it, like not updating and being kind of slow. And on occasion, it just wouldn't give me any data at all as I was trying to step through logic. So I turned it back off. Because I actually did legitimately try that for a while, and it was not quick. I don't know if it's the way that I have it set up or the project size or what, but yeah, it just was not very fast, and on occasion it just wouldn't give me data when I really needed it. So I had to stop using it, unfortunately. At some point I'll probably update it again and try it again. But for now, yeah, it was a no-go on that. Okay, so that is all of that. So the next thing that we have to show is, and discuss actually, is cascading shadow maps. So I'm going to open Paint. And we just switch to a decent sized brush here. Let's go with this guy. So I'll kind of use colors here to match kind of what we've done before. So we've talked a little bit about what happens when you stretch out a shadow map over the entire scene, right? And in fact, just to re-illustrate that point, I'll go ahead and run this one more time just for anybody that was not here when I ran that. Okay, so what we get now is our shadow map essentially looks like this, right? And these are the individual pixels of that shadow map. And the reason it looks that way is because it's being stretched out basically over 400 units, probably further than that actually, because of the draw distance of our camera. And so it's basically stretching this thing out over the entire terrain as far as we can see and then further, which is kind of a normal thing that you'd want to do, right? But obviously our resolution is not enough. And, one thing that we could do, obviously, is up the resolution of the shadow map. But you're never going to be able to up the resolution of the shadow map enough to have good resolution all the way out here, right? It's just not going to happen. And so the resolution for something like this makes sense for stuff that's off in the distance where you don't really have a lot of detail that's needed. But when you're up close, you really want to see those details, right? Like if we go inside here for a second, and we take a look at this, right? Like this shadow map is just does not have the resolution to handle what we need to handle, right? And the reason it jitters is because it's recalculating as we're moving the camera around, which is normal and expected behavior. That's how it works, right? But this is far too low resolution for what we need. And so what we need is cascading shadow maps. So if we think about before, what we have, or currently what we have, is basically what we're doing is this. Size, 4 pixels, is that not? It still seems kind of thin. I wish it would give me like the ability to set something thicker, but I guess not. All right, so we'll just roll with this. So this is our near plane. This is our far plane. And then we've got our sort of connecting lines here just to sort of visualize this, right? This drawing is not to scale, FYI. And so our shadow map might wind up looking, depending on light direction and all that other stuff. If you imagine this is looking top down, our shadow map might wind up looking something like this, right? So we do this, right? And that's basically stretching things out, right? And in the grand scheme of things, when you think about like our building in that scene is probably about, you know, that big with the little car like right there, right? And so, you know, this is obviously not what we want to be doing, right? And so what we want to do is we want to cascade the shadow maps. And when I say cascade, we want to split up this view frustum and essentially use different resolution maps or different maps for different points within the view frustum, right? So if I take, let's use a different color here. Let's use, I guess, this purple. Or actually, let's use the magenta. So if we were to split this up into, say, 4, right? We'll have 1, 2, 3, and 4. If we were to split this up into 4 different categories, right, or 4 different sections of this, we can then have a little bit more fine-tuned control. So 4, we'll just use this guy, right? That's the furthest out detail. You don't need a whole lot of resolution for that. You just need sort of a suggestion, because at really far away, that will look fine, right? Let me see. Coffee lava, not using VS for debugging. Shaking my head. Yeah, I know. I haven't gotten used to GF yet, right? So I'm trying GF. I'm also trying Seer as another debugger, right? But I'm not familiar with it enough to use it here yet, right? And I don't really want to fumble around with the debugger on stream, right? So as soon as I get more used to that, I'll probably be switching to that instead. Sleepy Mushroom, hello. Welcome to the stream. Good to see you. Naxnier, does the texture size stay the same? If so, you look the same direction the sun is pointing. Would it get more detailed? Stay, yeah. Would it still shrink around 4, right? Yeah, so that was basically what I was getting to. And so, yeah. Over on YouTube, Ahmed, happy to join the live session tonight. Awesome, welcome. Glad to have you here. So, you know, I'll color code this, right? So 4 would be this larger one, right? And then maybe we have, let's use indigo, I guess, for the next one, right? And so if we were to think about the next one, we would have something that maybe looked like this for number 3, right? So that would be 3, right? And so the shadow map itself would be the same resolution. So this one is 2K, right? And then so is this one, 2K, right? And then if we take a look at, I guess I'll use red next. If we go in one more, let's go about here, we'll say. And again, this is not to scale, but I think you guys should get the idea, right? This image is also 2K, but takes up significantly less space. And then if we go all the way down here, right, our 2K is really, really small, right? Obviously, this is not to scale, right? But I think you guys get the idea. So we're able to take that same size of a shadow map and condense it down further and further. And so what we're essentially doing is with each iteration with this, we're basically zooming in and capturing more shadow detail for the lowest level of it, and less shadow detail, but further spread out for the higher levels of it. Let's see. My first question was about how it operates right now. So how it operates right now is just 4. So just 4 is what we're getting right now. What we're going to implement is all of this other stuff. Why not just encompass 3 instead of 3, 2, and 1? Because 3 still will not give you enough resolution. You need multiple levels of it. And so our first implementation of this is going to sort of hard code things to use 4 maps, right? But depending on the scene, you may or may not need 4 maps. So we're eventually going to make that a little bit more configurable so that you can sort of slide and adjust that. But for right now, we're going to go with 4. And you'll be able to see once we actually demo what this looks like, exactly why we want those different levels. Crisp29, thank you for the follow. I appreciate that. Welcome. So basically you have a 2048 by 2048 render target texture, the shadow map. Yep. But each texel covers more area because the projection is larger. Exactly. That's exactly it. Yes. So why does it have to cover their areas too? So the part that I hadn't gotten to yet is when we talk about these different, we'll say these different maps, right? When we talk about these different maps being used at these different resolutions, we don't ever use them all at once in any of these situations, right? So anything within 4's area, which is right here, anything that's within that of your camera only uses 4. Anything that is within 3 only uses 3. Anything that's within 2 only uses 2. And anything that's super close only uses 1. And then what happens is that, so basically what you get is the further out you go, the less detail you have because it's more spread out. But yeah, I hope that makes sense. So what I'm going to do is I'm actually going to demo this first, because I already took the liberty of writing it off stream. And the reason I did that is because I figured it would be a quick, nice visual update for you guys to see. So, reset that first. Always bleats about the version. Okay. And I'll go ahead and build. You didn't really understand. Okay, so let me try explaining it another way. So let me go with this. So the further we go, you're basically here, right, as the viewer, right? The further you go out this way, right, the further out shadow map you're going to use. So for the space between your eye perspective point and this first section's end right here, right? So this number 1 space, we're going to use this green shadow map in here, right? Couldn't each cascade cover only its subfrustum instead of all of them? Yes, each cascade does cover its own subfrustum, right? So, I mean, theoretically, yes, that's what we're doing, I guess. Like I said, this isn't to scale. It should probably look more like... keep those. It should probably look more like... Can I erase this? Wow, okay. It should probably look more like 4 would be... Pencil tool. 4 would probably look more something like this. Oops. Try that again. I'm drawing with the mouse. I'm not very accurate with it. Right? It would probably look more something like that. I think that's what you're asking, right? I should have drawn this to scale. Maybe I should redraw this whole thing. So, what this originally was meant to represent was like, this is what we're doing now, right? This is what we're doing now. And we're transitioning to, essentially that, right? So we had that, we had, I don't remember what the colors were at this point, but let's say we have that, and then that, and then that, right? And this is, like I said, this is not to scale, but that's essentially the idea. If this was to scale, it would be much more obvious what those maps look like. So if I go ahead and run this, in fact, I am going to run this in RenderDoc because I want to show you guys exactly what this looks like. All right. First off, notice how much crisper our shadow looks with this, right? But yet, if I go this way and back up, like, it's not really degrading, right? It's not cutting off. It's not doing anything, right? And so I can come over here, and you know it's looking pretty good even from a distance, I think, right? And so if I go ahead and just take a capture of this. All right, so I have that. I also introduced a new mode that will help visualize this. So now I can hit Control 3, and we actually have a new mode that shows where those cascades are. So if I move the camera down a little bit here, we can kind of visualize. Let me back up a little bit more. Right? So try and get all of them in one shot. It's a little hard. All right, there we go. So the red on the bottom is the closest map. Then we have green, then we have blue, then we have yellow all the way in the distance, right? And so if we turn that on and back up, we can actually kind of see where that change happens, right? There's a seam right there between this level of shadow and this level of shadow. And this one's a little bit more obvious than the close-up ones. So we could always tweak how this is done and how it's calculated. So you can kind of see, if you look really closely, there's a little jitteriness there as we move, right? But up close, it doesn't really seem that way. And so when we really get up on something, right, that furthest out shadow map kind of gets pushed away. And then as we get up closer and closer, we can see that it gets clearer and clearer. So if I put away, if I turn this back off, we can actually see that seam right here. So if I switch back and forth between it real quick, if you look at this line right here, you can see it's a little fuzzier here and a little crisper there, right? And if you zoom in a little bit, or zoom in, or go closer rather, it gets even clearer, right? And so it looks pretty good up close, but also you can actually see it cascade off into the distance as well. So if we look inside of our sponza, it looks pretty good as well, right? These shadows are pretty crisp. And they do work with alpha transparency, FYI. And so, you know, there's lots of detail in them. And that is, you know, kind of the effect that we were going to achieve, or we were looking to achieve. If I turn this to lighting only, we can really see how that sticks out, right? So it looks a lot better, I think. And so if we come out here and take a look at the car in lighting only mode, we can see these shadow cascades a little bit clearer if we zoom out. I keep saying zoom, it's just move the camera, but so I hope that that kind of makes sense to you guys as far as to how that works, right? Let's see. First time in stream, but I've been watching your videos for some time now. You inspired me to start learning graphics programming. Awesome, and welcome. Glad to have you here. We have ads, and I'll read the rest of the comments just in a second. So for those of you over on the YouTube side, we like to pause ads, pause for ads. The Twitch side gets ads every 30 minutes for 90 seconds, give or take. And so not everybody there gets ads, but a lot of people do. So I like to pause the stream during that so that nobody misses any content. And so that's just kind of what we do. And so whenever we do that, it gives me kind of a chance to take a break and drink something to hydrate. So we got about 30 seconds left, and we'll be back. Run them ads. I'll tune into Twitch so you can get the ad juice. Awesome. Thanks. I appreciate that. Almost there. All right, cool. Ads are dead. So I like to just pause the stream so that you guys don't miss anything when ads come up, right? So it's once every 30 minutes, we get ads for 90 seconds. All right, let me check on the comments here. Next up, virtual shadow maps. Maybe. LSR. So I'm working on a simple game in C++, GLFW, GLSL, and the hardest part is not technical aspects. The hardest part is figuring out how to structure the code. Amen to that. Especially since there's like 10 ways to give 10 ways to do a given thing. Words. How do you go about deciding on a design structure for a given system? For me, I usually don't know the right way to do something. Usually don't know the right way to do something. And often end up restructuring things later. So understand that refactoring is a normal part of development. And anybody that tells you any differently isn't being realistic about it. Sitting there and trying to plan out an entire large code base, especially as something as large as a game engine, just isn't realistic, and it's not going to happen. And you're not going to get it right initially. It's just not going to happen, right? You can have some broad strokes of a design and maybe be able to stick to that, but if you think you're going to be able to UML an entire game engine and actually be able to stick to that, it ain't going to happen. And that's that is years of experience telling me that, right? So never be afraid to refactor your code and make it better. Also, though, know when to sort of stop the refactor tractor and get off of that thing, because sometimes it can be kind of addicting to just sit there and refactor stuff, and then you're not moving forward, right? So it's about balancing that. So I would say, usually the way I work with features is I get them working first, and then worry about structure later. Because if you structure everything and then you realize, hey, I actually have to change my structure to make it do this, then you've got to rewrite that code already, right? And chances are you might code yourself into a corner by doing that. So I like to get the feature working first, hack it in somewhere, wherever it makes sense to sort of hack it in. And then before you check that feature in, do a cleanup pass, organize it, and make it better, right? Make it more organized, make it separating concerns and all that stuff. Make those changes once you actually have the feature working. That way, if you get to a point where you actually break it, you can kind of roll that back and say, hey, what did I move here that caused this thing to break, right? And don't be afraid to commit several times along the way, right? commit and push code constantly, because if your computer's hard drive craps out on you, or you write a lot of code without committing, and then something breaks along the way and you don't know where you broke it and you don't have a version to go back to that works, that sucks, right? So just remember that, I guess. I hope that helps. Time Lord, thank you for the hydrate. Appreciate that. So it's not necessarily bad practice to rough out something knowing I'll go back and make it more robust and more structured. Absolutely not. I do that all the time. And anybody that has written a lot of code will tell you the same thing. I found over the years that most people that want UML are like management figures, right? They're not generally the people that sit down and write the code. And so generally speaking, it's much easier, especially on a larger code base, to get the feature working first and then refactor it into what it needs to be to meet whatever requirements, right? And make it robust from there. Okay, cool. Yeah, no problem. I hope that helped. Okay, so that is basically it for that. I did capture something. Yeah, I did capture a frame. Okay, so let's take a look at what these shadow maps look like. So if I go to texture viewer, and I think if we take a look at the shadow map pass, and note that we actually have 4 passes here, because this is how I'm doing it right now. This is part of actually what we were just talking about get it working and then make it right. So what we have here is not a fast solution, but it is a solution and it works, right? So we're going to make this more robust and quicker after the fact, but we wanted to get it working first. So the way that I did this is I basically repeated the shadow map pass and just changed the projection and view information each pass. And what that gives us is a slightly different shadow map every single time. So if we open up this first shadow map pass, and I'll go here to the last draw and go to outputs. Notice that it doesn't look like much, right? This is our depth. Why is this not? Okay, I guess it was just really zoomed out. So this is our depth texture, which you can see there is some detail in there, but there's not really anything discernible, right? So if we take a look at our second pass, and go all the way to the bottom, right? It kind of looks like a similar thing, right? But this time we can see that we've got a square down here, which is the kind of the corner of the building. Remember, we were zoomed way out, right? So we've got that. I might need to take a better example of this. Let's see what the third one looks like to help illustrate this. I probably should have been a little bit closer to details here. Okay, so here is the third cascade, right? And so this one is, again, a little bit closer. And if we zoom in here, we should be able to find the car around here somewhere. I think it's like right in here, and we can't really see it yet. So let's look at the last shadow map. And we'll look here. You know what? Let me grab a better example, because it's too far away for us to actually kind of visualize this properly. So let's do this. I'm just going to take it from the perspective that we kind of load up in. This will be much easier to visualize. Okay, so we'll take a look at the first shadow map. Right, so you'll notice that it's really, really zoomed in. If we take a look here, you can faintly see the outline of the car right here, right? So you can see there's a lot of detail in this map. You can see sort of the engine bay and the window cutouts and all that stuff. So all of that's been rendered in pretty high detail. That's the closest one, right? And then if we look at the second one, whoops. We look at the second one, it's a little bit more zoomed out, right? We have more of the building, but less detail on the car, right? Before we only had kind of the corner of the building. Now we have more of the building. Some of the inside is here, but much less detail on the car. If we look at the next one, we can see that we're zoomed out even further, right? And this line here, incidentally, is the edge of the terrain. So this whole gray area here is the terrain. And this right here is the sponza. So you can already see by our third shadow map how zoomed out this is. And for reference, the car is right here, right? So you could just barely make out the car. So the further that you zoom out, the less difference there is and the less detail there is, right? And then further down for our last one, we can really see how zoomed out this is. So these are the far corners of the terrain, right? So most of our shadow map isn't even falling on anything. And then the sponza object is barely even discernible in here, right? So that just kind of gives you an idea of the levels of detail that you get with these different shadow maps. Okay, so that is pretty much it in terms of how it works conceptually. Let's see. But it's possible to do it in a single pass, right? Yes, technically. But we don't have some of the things on the back end that we need to do that. So this is why I did it this way. So that's one of the things that we're going to be tweaking, right? There was a tweet by Sebastian Altonen. He talked about using a texture atlas 2K texture for cascades, 3 1K textures to draw them in a single pass. So you can do it that way. You could also use a 2D texture array, or you could use a 3D texture to do it and just sample the layers. But yeah, ultimately you have to draw the scene repeatedly, right? There's no real way around that. But yeah, you can do it in a single render pass, and eventually that's what we're going to wind up doing. So eventually what I'm going to do is we have this sort of shadow map pass here, and then we're going to have essentially a cascade shadow map pass that's going to be a specialized version of that that'll handle that for us so that we don't have to have a bunch of different ones. You like what John Blow said about LSR's comments, that it's not actually worth putting in the mind power beforehand and trying to architect a perfect system, because the more you work on actually making it and working with it, the more experience you get and are actually able to make well-informed decisions later. 100%, yes. And again, that's a voice of experience talking about that, right? And that's the same conclusion that a lot of developers who have been doing this for a long time, in any industry, we all kind of come to that same conclusion, right? That sometimes it's just not worth trying to plan out something that likely isn't going to work out anyway. Okay, so where did my... So we have this guy here. And this is a pull request that I'm putting up to go into the PBR branch. So I actually put this up on a separate branch, right? So I called this PBR CSM for cascading shadow maps. And this is going to go into the PBR branch. And the reason I did it on a separate branch is because it was an experimental feature of an experimental feature. And so this is kind of one way that you can use to manage that, right? It kept this implementation separate from the base PBR implementation until I actually got it working, and then you can move it in. And so basically what we have here is we have this sort of hard-coded notion of a max number of cascades, which is 4. And right now we're using 4 and always 4. So we'll come back, we'll make this more robust with more passes and things like that. But for right now, we wanted to go with 4 just as a way to sort of illustrate this and get this in and get it working, and then we'll refine later. So one of the things that we did is in the fragment shaders for both this and the PBR, we now take multiple light space matrices, so 1 per cascade. And you'll see that 1 per cascade thing pop up a lot. So we now have 4 shadow maps that need to be sampled. And again, we could do this with a single texture, we could do this with a 3D texture, we could do it with a 2D texture array. But for right now, we have them as separate, right? So there's a lot of optimizations we have to do around that anyway. And so I just kind of went this direction because it made it the simplest to get it working before we try to optimize it. So we have the first shadow map is at index 20 because it comes after all the terrain material indices. And then we have shadow map 1, 2, and 3, which are 21, 22, and 23. And then we bumped the irradiance cube out to 24. So we have 25 textures here, right, to render a terrain, which is a lot, right? We don't want that many textures. And so we're eventually going to refactor this again to handle some of that stuff. But there's actually some stuff that came up in addition to this that I became aware of that we actually need to handle as well. We'll get there. So we updated our sampler arrays, right? So we added 3 more textures to each, right? So that's 5+ instead of 2+. And then in the DTO object, and this is the same for the terrain and for the PBR material shader. This is the data transfer object from the vertex shader to the fragment shader. We changed light space fragment positions to be an array of 4, and we basically just have 4 of those now. And then we also have cascade splits. So the cascade splits are literally these points. Where did my... So the cascade splits are these lines here. These guys. Right? So that information is fed to the shader so that we know where those frustums are and can figure out which one of these maps we actually want to sample. So that's how we do that. So calculate PCF takes in a cascade index. That's how it knows which one to sample. Right? So we just do shadow map plus cascade index, which will be 0 through 3. So it offsets into that array. Calculate unfiltered, same concept. We just offset by an index, right? Otherwise, it works exactly the same. Calculate shadow just takes that cascade index and passes it on to PCF or unfiltered. And then here is where we added the sum logic for our mode 3, which is our cascade view. So I don't know, I think I showed you guys what that looks like, right? So that's our mode 3, which is a new mode. And then the biggest change here is us actually determining what our shadow cascade is. So what we do is we take the fragment position that's passed over to us from the vertex shader, and we take that, turn it into a vector 4, multiply it by the view matrix, and that gives us the fragment position in view space. In other words, where is it in relation to the camera? We take that and we say, okay, what's the Z coordinate of that? Meaning how far is it away from the camera? And we mark that as depth, right? We just take the absolute value of that because we don't need negative, right? Doesn't matter. We then get the cascade index rather, based off the current fragment's position. So we look through those cascade splits again, which are these lines here, these distances from the camera, right? We look at those and we say, hey, if the depth is less than that, then use that as the index, right? And we just kind of work our way through that, and that's essentially what tells us what the index is. We start the cascade index at -1. If for some reason that never gets changed, we just default to the max number of cascades, right? And then we go ahead and call calculate shadow on that. And last, we have our colorization down here, which is if we're in mode 3, we just multiply the color by one of these 4 colors, depending on which cascade index we have. And these changes are the same between the shader for terrains and the shader for the PBR, right? So that's the fragment shader for terrains. This is the fragment shader for PBR. It's the same stuff, right? The only thing that varies slightly is these indices, but that's it, right? As far as the vertex shaders go, the changes are the same for both shaders there as well. So we have our max number of cascades. Our light space is now an array of those. And then we got rid of our ambient color and replaced it with cascade splits for now. So we were talking about getting rid of that ambient color before. Well, it turns out that cascade splits fits right in that same size. So for right now, that's what we've done, and we've just essentially passed that in as a vector 4. But really, it's just 4 floats that are distances from the camera, right? So vector 4 just happens to be the right size. That could be an array of 10 floats or whatever. So we may eventually wind up swapping that out, but for right now, that's what we're doing. So the data transfer object just has this light space fragment position being converted to an array, and then the cascade splits get passed to the fragment shader. And then we have some padding down here. We had an erroneous use PCF here, so I removed that. Here we're just copying stuff over to the DTO object. And then here is where we're getting the light space transform fragment positions. So essentially what we do is within the vertex shader, we loop through all the cascades and set up the light space fragment positions for each one of those cascades. The changes between that and the PBR shader are identical. The shader config also received some updates. So we now have, to support those arrays that we were looking at, we now have 4 light space mat4s and 4 shadow samplers, and then also our cascade splits, right? So that's just the change to the shader config to support that. Same thing goes for this side, right? So terrain, PBR, same thing, right? Also, the shadow map terrain shader config file, that had cull mode of front, and it's now cull mode of none, right? And that's just in case we ever have something that's like under the terrain. We want that to be shaded as well. So kmath, we added a kpow, right? Which is basically just calls powf, right? So it just raises x to the power of y. And there's the front end function for that. Shadow map pass just has cascade changes, right? So we have the split depth for the current cascade and then the cascade index. There's no changes to the C file for that whatsoever, which was one of the reasons I did it this way, is because it made the changes to that basically nothing. Under renderer types, we have a new debug view mode. So that's that mode 3 I was talking about, where it shows cascades. So we have that. Material system has a few changes. So one of the changes is the directional light space set now takes an index, right? So that's per cascade. So if we take a look at this file, whoops, I need to expand that. We've updated the PBR map count from 7 to 10. We added our sampler indices here. And then we updated, same thing as over on the shader side, right? We changed ambient color to cascade splits in both shaders. Here's all of our shader positions, locations rather. We load all those up, right? Here we get them from the shader config to get the actual locations. Same thing for both shaders, right? It looks like a lot of logic, but it's mostly stuff we've already seen. So we assigned some defaults to the directional light space. We just use identity matrix by default so that there's something there. And then basically we're going to see this a bunch of times where we basically do things per cascade. And so per cascade, we're basically just adding an index to a lot of stuff. So there's that. Here's the cascade splits being added. Here's the light space shadow mapping per cascade. Again, we have that loop. I changed the bias to be a very, very, very small number, just to eliminate shadow acne from the very far out shadow maps, because we were getting a little bit of shadow acne there. And so I just setting a bias to this to fix that. Again, we should probably make that read in from somewhere, right? So I've got a hack note there. We probably ought to have some sort of setter for that. And we might even want a setter per cascade, but I'm not sure if we need to go that granular or not. So a hack that we did was we used the cascade splits by passing it to ambient color. So we'll see that in the scene pass. We'll actually see that the splits get passed over into the ambient color, and then we just kind of use that, right? So when we set material system apply global, let me do this. Let's see, where's the... Here we go. So in the function signature, it takes all these parameters, right? And one of those parameters was this vec4 ambient color. And so we're still using that as ambient color because we haven't gotten rid of the original material shader yet, but eventually we'll be renaming that too. So here are the shadow maps being bound. So again, per cascade, shadow maps per cascade, one for terrain, one for PBR. Shadow textures is just by index. So when we set up the shadow map, we do that by index now. So we now pay attention to what this index is and just set that. Here's our update to directional light space. So that uses an index now that was newly added. So shadow maps, right? So before we were just adding one, now we're adding all of them, right? And so again, that's just by index. More stuff by index here. So this is, I think this is the creating the default PBR material. So this is just setting up texture maps for that. And then setting default textures to that. Setting up maps for the material, right, to actually be acquired. And again, here, same thing for terrain. Those same exact steps all the way here for terrain, right? So it looks like a lot, but really it was just kind of doing the same thing in more than one place. And again, that's probably something that we'll have to come back and refactor a little bit. Here's a function that we added to our game keybinds to just be able to set the mode. So whenever we press Control 3, it sets the render mode to cascades. So there's that. Here's the game state, which now has 4 shadow map passes instead of just 1. Here's the scene pass. So this received some updates, nothing particularly huge, just basically doing things multiple times per cascade. So one thing that we have here is we have the render graph source. Instead of just being a shadow map source, we actually have 4 of these. So I should probably actually show that first, so we can see the render graph. So let's actually look at that. Simple scene, I made a small change to just allow not passing a frustum. That's all that is. Testbed, here's for our cascade mode. Eliminated a bunch of code that we don't need anymore. And so basically what we do is we generate the splits up front instead of doing all this other stuff. In fact, let me actually just pull up that file because that might actually be a little bit easier to visualize. So what we do is we get the camera and the viewport, we get the near and far clipping planes, and then the clip range. We get a min Z, a max Z, a range of between those two, and then a ratio of those two. And then we have this sort of multiplier that we use to indicate how much we kind of want to split things, right? And I've found that this 0.95 seems to be kind of the right thing to use. So when we're generating the splits, what we do is we basically iterate through each cascade. And incidentally, this is the only time I use C++, for those of you paying attention. And we have adds. So we just got about 90 seconds of ads. Let's take a break real quick. Stretch. Modern C++. Yep, that's it. It's the only time I use C++. And if you notice on most of my iterators, I type ++C, but this time I type C++ because that's the only time I use C++. So we got about 35 seconds left, and then we can kind of jump back into it. Ten seconds. A little more water. Need to hydrate. All right, ads are dead. Cool. So, when we're calculating these splits, we base it on the camera frustum, right? So we do we say, okay, take C plus 1 and then divide that by essentially 4, okay? And then we do take the minimum Z and say, okay, take ratio and raise it to the power of this P that we just calculated. We then take that, or that's actually used down here. We also calculate this uniform here. So we take min Z and add range times P to that. And then we use this right here to actually calculate what that distance is. So we take our multiplier, we multiply that by log minus uniform plus uniform, right? And that gives us our final distance. Well, almost final distance. We then basically clip that into the range, right? So we subtract the near from that, divide it by clip range, and that gives us our final split. So we generate 4 of those, and that gives us our individual, 4 splits, as it were. And then we generate defaults for our lookats and our projections. We have 4 of each because we may have that many projections and lookats for each cascade. And then when we do the shadow map pass, we basically do the same code, but per cascade. So we have this last split distance, which we start at 0, meaning we're starting at the close, at the near clipping plane, right? And then we go ahead and grab a pointer to the cascade. So that's just the current shadow map pass that we're on. Again, we're using C++ here, folks. C++. It's the only time you're going to see it. And then all this other stuff is basically the same, with the exception of this little section right here. So we get the split distance, and then we adjust those corners that we were getting from here. Instead of doing the entire array of corners, just covering that whole view frustum, we now just take a portion of it. So we do that by basically applying that split distance to each of the corners, right? And so we have a loop here from 1 to 4, and then you'll notice we do I plus 4. So the reason we do that is because we're essentially modifying the far plane of the frustum, and we're pulling it in. And we do that once per split. And then we have the actual corners that we're looking for each of the splits, right? Everything else here is the same, with the exception of we just add indexing to all this stuff, right? Okay, so all this stuff is pretty much the same, with one more thing that we added. I just got to find it. I think it was before this. So yeah, this is it right here. So when we're saving off the look at and projection matrix that we generated up here, we also store the split depth on the pass. And so we pass that into the shader, and that is ultimately what we wind up using, right? And I think that's mostly it for this. The only other thing that's really important to touch on is, and I think we can actually look at the diff for this section, is down here. Let's see. So our function pointers obviously had to have an update, right? We have to do that per cascade. So you'll see some other per cascade loops in here where we have stuff that needs to be done per cascade. Kind of makes sense, I think. Our shadow map passes are generated. We generate 4 of them, as you saw in RenderDoc, right? So we just have shadow map pass, and then what we do is we generate a name for each one of those passes, 0 through 3 in this case. But otherwise, all the settings are the same, so that when we come down here and we hook up our render graph, we basically come into our scene pass, and we set up syncs for each one of these shadow maps. So we have 0 through 3. And then when we link those syncs together, we have into shadow map 0 on scene, which is this guy here. Into that sync, we put the depth buffer from shadow map pass 0. Shadow map 1 has shadow map pass 1 depth buffer put into it, etc. Right? So we've just hooked that linkage up here, and yeah, right. It just kind of, it works. It does the thing. Because of all the stuff that we've set up to this point, that's really all it takes to hook that up, which is pretty awesome, I think. All right. Whoa, we have a raid. Bar Interactive, thank you for the raid of 4. I appreciate that. Welcome to the stream. What are you up to tonight? Welcome aboard, raiders. So let me just expand my chat here so I can read chat. Quota raid, quota raid, quota raid. Awesome. Well, welcome raiders. I appreciate you guys. You're modding Lethal Company. Modding video games. Awesome. That sounds like a lot of fun. Followed and subbed to your YouTube as well. I appreciate that. Thank you so much. And I'm going to give you a shout out. So everybody make sure to follow Bar Interactive. There we go. I think I got it right. So definitely I'm going to do the same for you at the moment. Just toss you a follow. There we are. So thank you for that. I really appreciate it. So what we're doing here is we're basically looking at our implementation for cascading shadow maps on our game engine. So what we're doing is we're developing a game engine completely from scratch using C and Vulkan. And so that's a project that we're working on. Now we're live streaming it. It started off as a YouTube series. And we just kind of live stream it here on Twitch now. So it's called the Kohi game engine. We're building it completely from scratch. It's an open source game engine. It's available on GitHub. It's 100% open source, 100% free. There will never be any royalties or fees or anything of any kind associated with that. It's Apache 2.0 licensed, which basically means you can do anything you want with the code. All that I ask is that if you use it, that you just say, hey, I used Kohi, and that's it, right? And so, yeah, all of the code is available here in the repo. So there is that. The project's been underway now for about, I think it's coming up on 3 years, actually. We built it completely from scratch, right? So, yeah, that's kind of where we're at. So at the moment, we have. I actually closed that too soon. So at the moment, we're working our way through a sort of to-do list. Let me switch to the branch that we're currently working on. So we've got a roadmap of things that we've done and haven't done, right? So we've got a whole list of features here that are planned out, and things that are checked off and done, and things that are still coming. So we've got quite a bit of work done. We've got quite a ways to go, but yeah, we've done the whole thing on video. So all right, open source engine, that is awesome. Is it more for 2D or 3D? So right now it's all 3D. But there's no reason it couldn't be used for 2D games, right? So sprites is one of the things that I have to add, and that's the big thing that 2D games use. But 2D is really just a subset of 3D. And the engine could be configured without too much effort to do 2D games, rather. So, yeah, definitely it's both, I would say. So let's see. You also stream making games and post YouTube content. I'm a level designer, also part of the pirate crew. Awesome. Okay, that's pretty sweet. Well, I will definitely find your YouTube channel and subscribe as well. Appreciate that. Why do you use color with a U? What's wrong with color with a U? So I guess that's more of a... I worked with a lot of overseas teams for a lot of years and just kind of picked up the habit because all those code bases were that way. And so that's just kind of something that stuck with me, is spelling stuff like that, right? I kind of use British spellings for a lot of stuff. What's the main code language? It's all written in C. So I don't use C++ here at all. I use C. And it's using Vulkan as its rendering backend. So, yeah. Found you in the advertising channel of the Pirate Software Discord, by the way. Wording tonight is escaping me. Well, that's awesome. Yeah, I always... Thor is really good about allowing people to sort of advertise in there. So, thankfully, that's a place that I can also mention that I'm streaming. And I'm using the Heartbound soundtrack, if you didn't notice. So he's been really awesome about letting people use that as well. So just adds a little something to the stream, I think. So yeah, welcome. And I'm glad to have you guys here. So what we were doing was we were just finishing up looking at a pull request that I had put in for cascading shadow maps. And I think we were most of the way through it, actually. So we kind of went through this material system updates. Again, this is just adding splits and per cascade data. That's all this really is, right? There's not really... It looks like a lot of code. It's really not, right? It's literally converting a single shadow map source to multiple shadow map sources. So that's essentially all that was left in that. The scene pass, again, just taking non-array things and converting them to arrays, and then adding our cascade splits. And I think that was actually it, right? So this is going to go into the PBR feature. However, before I do that, I did want to update the to-do, because we now have cascading shadow maps in place. We still need to do some... we still need to do like a performance pass on that badly, right? But there are some other things that I want to work on the back end before we actually do that. So let me see. Is there anything else I forgot to check off? I think I also had... Didn't I have something in here for sorting? I guess I didn't, because that was another thing I knocked out. Let's do... Under engine general, I want to add a new point here because that's worth noting. Generic sorting functional library, because we added that as well. And then also in the change log, let's see. Did we add anything about this yet? I don't think we did. So we got to add that. Added cascading shadow maps. Right now, limited to 4 cascades. And then, oh, I did put the quick sort thing in there. Okay. I put it here. That's good. Okay. So there's that. Actually, if I can type. Commit. Updated. Change log. And to do. And I'll check in the version stuff too. Why not? Okay. Big respect for using NeoVim. Yeah, I love it. It's my favorite editor. Ruche, I love the Yar bongos and Yar rabbit. Yeah, those Yar bongos I think is my favorite. My favorite emote. That one. Unfortunately, I can't do it over on the YouTube side. I wish I could, but I can't. But yeah, over on the Twitch side, there's a Yar Bongos emote that is from Pirate Software's channel that I love. Okay, so we have this. I'm just going to make sure I'm going in the right branch. Yep, create the pull request, and I'm just going to override it and merge it now. Yeah, that should be good. And delete branch. Cool. So go back to the PBR branch. Yeah, I typed my password wrong. There we go. Okay, so cascading shadow maps is now available. Whoa, what are you doing, Windows? Okay, that was interesting. Windows just kind of freaks out like that every once in a while. I've got like different DPI displays hooked to my machine, and sometimes it just mistakes which one it's actually looking at. So all of that code is now pushed to the feature PBR branch on the repo. And so if we take a look at that, this is where the actual latest code is. So if you guys wanted to take a look at that and pull that down, you would want to look at this branch because the last probably couple months of work has all been in this branch. And then at some point we'll merge this over. But before we can merge that over, there is one major thing that I ran into that unfortunately is going to be a problem. So if I go here to my website, I wrote up an article about descriptor aliasing in Vulkan. And briefly, I'll talk about what I mean when I say descriptor aliasing. So if I take a look at, let me just close this and open, let me open PBR shader. Let's open the fragment shader. If we take a look down here, where is it? Did I scroll too far? Probably did. Here we go. Okay. So if we look here, we have two arrays of samplers. So one of them is type sampler 2D, the other is sampler cube. And these are basically on the Vulkan side are combined image samplers. And it's an array of those. And so you'll notice that we're using the same descriptor set in the same binding for both. And this is allowed via a extension in Vulkan. And this is what they call descriptor aliasing. Now, this is something I've done in OpenGL many times throughout the years. Never ran into an issue with it. It works fine on this setup. It works fine on most setups that I've worked with. However, I found out that it does not work on MoltenVK/macOS, which is a problem because we officially support that platform. So in order to get descriptor aliasing to work, this was all of the stuff that I had to research into actually getting it to work, right? And basically, this was what I did to get it to work. And then this is all the stuff that I tried to get working for macOS. And ultimately it didn't work. And there's something, there is a change set out there for MoltenVK that supposedly fixes this. But I've decided I don't want to wait on that. And if it's basically something that was fixed at one point and I guess had a regression. And it's something I don't want to rely on anymore. So I'm going to change it to not do that anymore. Of course, macOS doesn't support that one little graphics feature. I've had macOS shader problems before. So the interesting thing is this actually isn't a Vulkan issue. It's not a macOS issue per se. It's not even a Metal issue. It's a MoltenVK issue. It's in the translation layer between those two. That's actually the problem. And so basically on macOS, all of the fixes for this counteract each other in the latest version of the SDK. And they, like, I read some forums on this on different pages, there's links all over here, that swore up and down that if you just downgrade to a previous version of the SDK, it worked. No matter how much I tried that, I couldn't get it to work. So I've decided that I do not want to rely on this. And I want to change the way that I do it, right? So basically right now, the reason I did it this way was for convenience. And this is one of those times that it's coming back to bite me in the ass, right? So basically our descriptor setup, for a little bit of background here, is we have descriptors set up by change in frequency. So we have these global ones, which are changed once per frame. And that's where we'd use like projection and view matrices, things like that. We have the instance variables, which is like per material instance, you can think of it. So for every instance of a material, for every type of a material, you would have one of those. So for example, you'd have one for a wood material, another for a metal material, for example, one for a snow material, for example. And even if there were multiple objects that used that same material, you would only have one update for that material specific instance, right? And then you have local, which is per object, sort of in the scenes, right? So it's like the example I use here is for every physical traffic cone in a scene versus the traffic cone material, right? And so that can contain something like the model matrix as opposed to surface properties, right? And the difference is global and instance are implemented as descriptors, right? Your typical descriptors, versus our local is implemented as a push constant, right? Because push constants are useful for things that are updated often, and so that's what we're using that for. And essentially, what we're doing here is we have two descriptor sets, right? So we have one for global and one for instance, right? Within these descriptor sets, we have two bindings. So there's one for the uniform buffer. That's all of the random material data and all that kind of crap that we post over, right? So we have a global uniform buffer and an instance uniform buffer. And then we have an array of samplers as the second binding, right? And as far as Vulkan's concerned, it doesn't care what kind of sampler we use, which is why I did this, right? Because as far as it's concerned, a combined image sampler is a combined image sampler. It doesn't care. And so what I did was I was just like, okay, well, basically how many textures does the shader have? And we'll just create an array of that amount, and we're done. The problem with this is the actual shader conversion from GLSL or HLSL over to SPUR-V basically doesn't interpret this right. And if you have to mix sampler types, that becomes a problem. And there's no such thing as casting in GLSL. So what we're essentially doing here is, for example, in the PBR shader, and this is one of the things we have to modify as well, is in the PBR shader we have sampler 2D for albedo, normal, metallic, roughness, and ambient occlusion. And then we have a sampler cube for the irradiance map. And as far as Vulkan's concerned, these are all the same. As far as the shader is concerned, they're not. And that's because you have different texture constructors or texture function calls and so forth for those samplers, right? So the aliasing thing got me around this, but unfortunately there are issues with it. Namely, all the crap I had to do to actually get it to work in the first place, but then all of this other fallout on macOS. And that also makes me concerned about certain Linux drivers and stuff. I wonder how those are going to handle it too. Especially stuff that like doesn't support some of the extensions and whatnot. So I do worry about that. So we are going to change this up. And instead of having 2 bindings, we're going to have multiple bindings, essentially. So we're still going to have just one for the uniform buffer. That's good enough, right? But our samplers are now going to be split up. And we're going to split our samplers up probably 1 binding per sampler is what I'm thinking. And what we'll do is we'll also allow array types. So there's like a sampler 2D array or a sampler cube array, things like that. We'll still allow arrays, but we'll actually specify that in our shader. So when we go to load a shader config, I'll pull up the PBR shader config. So right now, as far as kohi is concerned as well, a sampler is just a sampler, right? So we have the uniform here, type of sampler, and it's just sampler all the way down, no matter what kind of thing it actually is. So what we're going to do is we're going to define the different types of samplers through here, and allow those things to also be arrays if we want, and maybe even specify the size of the array in here. And then when we parse this, we'll actually set up the bindings correctly on the back end. And that will be the most flexible layout that we could possibly have. Apple should just support Vulkan, not while Metal's around. They're not ever going to do it. Cool beard, thank you. Appreciate that. First time chat, by the way, welcome. Yeah, I wish they would just support Vulkan, but it's never going to happen, right? In fact, at some point, what I'm going to wind up doing is probably writing a Metal backend instead of relying on Molten VK. Because Molten VK is basically, it's great for testing, but like production level code, I probably wouldn't want to run it, right? It's never going to be as performant as just going straight Metal. So that is what we're going to have to do, I guess. Okay, so this is basically what we're going to wind up starting on tonight. And unfortunately, I have to get this done before we can actually merge the PBR branch in, because otherwise it's going to break it for macOS users, which is fun. So, I'm thinking what I might do is create another branch for this. So gets checkouts PBR descriptors, I guess. And that's what we'll just have to use for now. All right, so we already have the capability of determining all of these other uniform types, right? And I think the same logic, if I remember correctly, is used for attribute types. So really all we need to do is expand the sampler to be multiple types. And then I think each one is just going to have to be its own binding, I guess. And then there will be cases where we can kind of group the things into an array where it makes sense. And we'll just kind of go from there. What is... Oh, we have adds. So for those of you who are new here, one thing that I like to do is I like to pause the stream whenever ads come up on Twitch, and that happens once every 30 minutes for 90 seconds. And out of respect for viewers, I like to pause the stream and wait for ads to complete so that nobody misses any content, right? Because nothing sucks worse on a programming stream than having ads come up and you see code and things being written and discussed and talked about, and you have no idea what's going on, right? And nobody wants to have to go back through the VODs and search for that stuff. So I like to just pause the stream over on YouTube. I know you guys don't get ads quite the same way as we do on Twitch. And not even everybody on Twitch gets ads the same way, depending on region or locale. Sometimes you'll get 30 seconds of ads, sometimes you won't get any ads at all, sometimes you'll get the full 90 seconds. So, yeah, I'd like to just kind of pause the stream and wait for those to go by. And we're just over 10 seconds now, and we'll be right back to it, right? All right, so... All right, ads are dead. So thank you guys for pausing with me. So for those of you who had ads running, I do like to pause the stream for the 90 seconds or so that the ads run every half an hour, just to make sure that any folks that do have ads up on the screen don't miss anything, right? Okay, so I want to go ahead and look up the shader loader, because that is going to be the first place that we have to look. Let's see. So this is shader stages, calling. So this is basically the logic that parses this file over here to the left. Okay. Let's see. Here are the types here. So we have the field types. Okay, so here's all the vectors, the integer types. Where is samp or sampler? Here we go. Okay. So this is what is going to have to be added to. I think there's only just one place that looks at this. So, do we have... I think what I might do to maintain backwards compatibility is to keep this as it is, but have the type change to sampler TV. So let's peak definition on this guy. So here's our known uniform types. So let's see. We don't just want a generic sampler anymore. We actually need kind of all the different types, which I actually need to look up because I'm probably going to miss some of them. Let's see. Here we go. Okay, so these are the different sampler types in GLSL, which should cover most of what we need. I think there's some missing out of here, though. I feel like shadow is a different one, although I suppose I don't need that. Let's see. Sampler 1D, 2D, 3D, cube. 2D rect. I don't think I've ever used that. 1D array, 2D array. Is there no 3D array? Oh, here's the shadow types. Yeah, shadow samplers. Okay. So we probably ought to define it for like most of these things. I don't know if that'll do all of them. I don't know that like multi-sampling and multi-sampling array. Maybe. You got a Lego Fortnite ad? That's hilarious. At this point, Fortnite is an entire platform engine for making other games. Yeah, it really is. It's like a subset of Unreal. It's absolutely crazy. Ahmed, it's your sleep time. Keep up the good work. All right, I appreciate it. Thank you for stopping by. I appreciate you being here. Have a good night. We're actually just about done for the night too, honestly, because I have to get up and work in the morning. So this is just me kind of trying to figure out what we're going to be doing tomorrow night, actually. So I think let's do this. I'm going to put a note in here. Oops. Implement these. All right. And actually, I'm going to take that same to-do note and drop it here. All right, that way we at least have a leave-off point. All right. So tomorrow night, this is what we're going to be covering. Is we're basically going to fix our descriptor issue and allow multiple types of bindings for this. And that will kind of be the more correct way to do it going forward. So, all right. Let's see. Who... Okay. So, yeah, I think that's going to do it for tonight. Let me drop my my socials here over on the Twitch side. Incoming spam for that. Over on the YouTube side, all of my social links are in my sort of profile there, so you can grab all of those. Follow me in all the places. I would greatly appreciate it. If you could spread the word about this channel, help me grow. I would greatly appreciate that. This channel is designed to be an educational resource for giving people an idea of what goes into writing a game engine from scratch and everything that's involved, and all the issues you run into along the way. So the more people I reach, the better I feel about it, right? So I appreciate all you guys being here. Thank you so much. And let me see who is who's online right now. Let's do... Let me see who I want to raid. Let's go with... If you guys have any suggestions, feel free to pop in and mention that. I'm just looking for somebody that I haven't raided before. Let's go with... Kind of trying to find game development here. Let's go with... This one sounds interesting. Okay, let me get... I'm going to raid New Jank. because that is a... Oh, yeah, that's actually a good point, Bar Interactive. Very good point. Let me look and see who is on, if anybody is on. See who's advertised recently. Okay, that's not a stream. Boy, some of these projects in here look pretty cool. Okay. Let's see what this one's all about, if they're still online. Okay, I think they're just watching a movie there. Yeah, I think I'm gonna stick with New Jank. I think that's what who I'm gonna raid tonight, because they are doing a NES style adventure game in Godot. So we are gonna go that direction. All right, yeah, I just want to say thank you to you guys so much for being here. I really appreciate it. I am going to drop a link over on the YouTube side as well, in case you guys want to check that channel out. There we go. And yeah, thank you guys so much for being here, and I will catch you guys tomorrow. See ya.